Hello, everyone. Today we are here to talk about testing, and this is a follow-up on an article that I have recently written about how we are testing software wrongly and how costly it is. So the article starts to defining what is unit when you are talking about unit test. And different of what many people think, unit should not be a public method of every class. Instead, a unit should be a package which will contain your domain, right? So, and instead being writing unit test per method, you should be testing the behavior of your domain package. And we are going to see a little bit, understand this a little bit better and towards the video. And the next thing that we talk here, it is why testing, doing unit test per class, it is problematic. So it is because if when you are writing a unit test and you write unit per class, you are not focused on the behavior of your system, but instead you are focused on the implementation code of your let's say domain, of your domain. So, and the problem of this is because now that your test is written towards the code, when you go and try to refactor that code, you will break all the tests, and consequently you will not have the test to help you, give you confidence that your code will still be working after the refactor, but you also have to rewrite all the tests or fix the test that you have now is broken after your refactor. So you lose the two important things. You lose the confidence in writing code, and you now start to delay your implementation because you have to fix broken tests, right? And to not mention the problem with mocking, right? Because when you are writing tests per method class method, you have to mocking every dependence of that class. And we know that the most of the bugs that raise in a software, it is linked to the communication between different components, different classes and methods, right? And you writing testing that only that method, you will not have a guarantee that your class guarantee that your domain behavior, it is guaranteed that it would continue working after refactor or after we will add a new feature to domain logic, right? And let's one thing that you need to start when you are trying to write better tests and test it properly, you need to learn how to organize your code. And I have also wrote an article talking that you are structuring our software incorrectly because you are organizing our code by types, right? You are leaving all the types together. For example, you are creating a package for services, you are putting all the services there. You are also creating a package for repository, and you put all repository there. You are not organizing by the domain that you are of your system. So for example, to summarize that part, you should be structuring your code that reflect the diagrams that you write for that code. For example, we are here. We are going to use a code example, and you are going to take this trading system as an example, and you're going to see here that this trading system has three components, right? You have a feed component and a component, let's say model. This is a model, separate model, and have another forex model and runner model. And inside you have different components, which is signal, price, and in forex we have all this here. When you go to our system, we can see that our system also match the diagram, right? So we're structuring as we see on the diagram. For example, if we cite feed, we should see two different components inside the domain, which is price and signal, which it is match what we have here. And the same way, when you go in forex, inside forex, you can see that our system, it is in the code, our code, it is matching our diagram, right? And now with that we are now identify what it is a very good unit that you want to test, right? And following up on this concept that we need to have in order to write good tests, we need to understand some encapsulation, code encapsulation, that you talk a little bit here. For example, instead of having loads of entry point to our component and have this very coupled code with no well-defined boundaries, we should be writing code and organize our code in a way that we have low coupling and very cohesion code. So cohesion means everything that changes together stays together. So no more code organized by type with let's say package repository with all the repositories together. Instead, we are gonna create a package per domain logic, which you, for example, component, product, user, and you want to stay everything together, and exposing one single entry point for your system, for your package. In this case here, you're gonna have a service, and they will be talking to each other to the others components, but it's only with that public entry. And therefore, because you have this public API, or with all behaviors for that component, you can write a unit test exploring from this entry point and cover all the behavior of the package. With a better example, for example, here we are organizing our components, and you can see that inside portfolio, for example, everything it is package local, no accessible from outside of this package. Only the portfolio service, it is open for public. And here we will describe all the behavior or functional methods for our component. And the other thing that you can see that is also open, you can see the locks here. It is DTOs, because you need to return DTOs when the other component calls it, and also factory will be called from outside in order to build and all the classes and instantiate all the classes necessary for our portfolio service implementation, right? And everything else should be inside here. This is to build boundaries properly, because that's the most important part on a service and on a system to keep healthy. It is to have well-defined boundaries. And when you talk about boundaries, you need to also build boundaries on the model level. For example, we have here the API, and because we have the API here well defined, we know that external modules will never access this area of the system, but we will always go through the API. From the API, this way you can refactor everything here without care about the consumers, because the consumers will always be seeing all this part and not see what's happening inside our model. So, and to ensure that in Java, with Java 9, from Java 9 we started to have modularization, and here we export the area that will be accessible from other modules. The next thing it is to see how we write tests. Eventually we have here the tests area, and we start to write unit tests per package, and we are covering only we are writing tests looking at what is public from kind of outside, right? And the first thing we start here is to define a new way to name our tests, and this should be using the portfolio domain should, because this should help us to read better our tests. And for example, here if you look at the structure, you don't even need to look at the test itself. You can see that this portfolio domain should update portfolio balance, should create stop loss order, should create stop loss order and take profit order, and should handle the stop order when price changes, and so on and so forth. Here you are describing all the behavior of this package, and you are covering all the behavior that is this package provides. And this way you can refactor everything inside the other classes, and this test will still be will not break, because it will be looking to the interface itself and don't care about the implementation, right? And when you are talking about tests, it's so the other thing that we do, we never use mocks for internal things that we can just use the real implementation. For example, the only thing that we are gonna be mocking, it is external services or external packages. So for example, portfolio will require risk management, order service, and event notifier, and only for those external packages. So the other package, we mock those, because it is not part of our domain logic, could be calling something else. So then you only will mock those, and let's say external service as well, database or external APIs, those that you will be also mocking. So in the other thing, you just make sure you are calling those external components properly, and that's it, and no more mock hell. I don't know if you guys know about this mock hell concept as well. When you create too much mocking, and you losing the ability to test the behavior of your component, because you are mocking too much. So next step, when you're talking about boundaries and write proper tests, we first build boundaries, and you start from the smaller part of when you look if you go back to our article here, you can see how to implement the test automation strategy. It is to first start small, and in small in this case is not the methods, but the small in this case it's the unit, and the unit we have just learned that the unit, it is the component itself. Okay, and then we progress towards testing the larger, and it's very important as well. For example, here we are testing individual components, but we also need to test all components working together in order to provide a proper let's say provide what the system is supposed to do, all the modules. So then we need also test the combination of all packages, and you do that to using a module test with Cucumber, right? And we start writing. We use the Cucumber for that, because you can describe very product scenarios for our component or module, and we then can also, after define those, we need to mock what it's external to our module. On this case here, we are talking about Forex, right? So when you want to test that everything here working together, it is behaving as expected. So this is not important for our test. So we mock that module when we will do it here, and give what we want to test. And in this case, we are giving signals of buy and sell from the feed, and then after we are testing if you in the end of we had what we expected from this module. And the same, we are not testing the feed here, but on the feed itself, we need to also test that all components working together is behave as expected. And here in this case, we have two scenarios covering that we are getting what we're supposed to get, right? And next step, see if I remember anything else. So another thing that we are speaking here, it is the how code coverage can be dangerous for our day-to-day when you are trying to achieve let's say achieve good testing and high confidence in our deliveries. It is if you are following the rule of 80% or trying to add very high test coverage, or let's say it's not test coverage, but a number of lines basically that it's covered on your test, rather than if you're not measuring the behaviors percentage but the lines of code. So, and that's not that can be dangerous, because when you have this restriction, your developer will be let's say distracted with those metrics, and not focusing in add tests to cover the behavior itself. So, and it's very dangerous. So, and here I'm quoting some very famous guy from the community, like Came Back, which is author of the book TDD by Example, and he's answering how much unit test assistant should have. And he is saying here, I get paid for code that works, not for tests. So my philosophy is to test as little as possible to reach a given level of confidence. So what he's saying is what matters is the confidence of how much confidence you have that whatever change you add in, you are not broken things. So you should not be aiming for percentage of lines that it's covered with tests, but instead you should be writing tests that cover behavior, and and by doing that you should get a fairly level of coverage anyway. But you should be looking from this perspective rather than the metrics and trying to please the management, right? That cannot see those things. And also say here, Marty Follower is asking the question if tests can be too much, and he is saying of course it can. You are testing too much if you can remove tests while still having enough, right? So be careful with those, because it's very common that people tests too much, write unit test every class, and write component test that will be covering other area, and then with end-to-end test is covering more things which it was already covered. So in our case, the next level that you should be moving after the writing test for component test, you should be writing end-to-end test, which will be testing the communication between all parts of your system. In this case, here is different libraries, but for example, you could just move feed into a microset, for example, and this end-to-end test would cover these two systems talk to each other and make sure everything works from the user perspective. That's a very important thing. When you're writing end-to-end tests, should be covering from the user perspective. For example, a user can log in, a user can make deposit, a user can see its balance. It should be a very high level, should not be again testing requirements from that you already covered by your component test, and where you could manipulate and control the inputs and outputs and be sure that your system it is matching the requirement that you need for your system. And I think that's it, right? So we covered what it's unit. We covered the different level of tests. We start for unit, go to component, then do end-to-end test. End-to-end test would be using also this language that Cucumber provides. But then we would be calling from outside and calling the external API. And we also talk a little bit how you should structure your code in order to give you a good way to test things properly. If you like this content, consider to enroll to my free advanced Java course on Udemy. And it is free, and you can just enroll and watch more advanced content, and I'm sure you'll enjoy it. So check it out.